everybody. Today we are talking about our Clover experiment. So we are going to kind of go through a little bit about what we're doing our experiment on and start thinking about our hypotheses for this experiment. Before I go into that though, I want to talk a little bit or just kind of do a little review. And I know we just got done doing this in our Google Meet, but I just want to again review the different types of hypotheses that you can have. Again, the null, which is new. The null, again, means that whatever you're testing has no effect on whatever you're measuring. So with the minion one from yesterday, the type of fruit that we gave the minions or showed the minions has no effect on our heart rate. Again, what that would look like is if I show them a banana, an apple, I think it was an orange, no matter what type of fruit I show them, their heart rate for each of those is the same. That means that fruit has no effect on, type of fruit has no effect on their heart rate. We also talked about these other types of hypotheses called alternative or alternate hypotheses. These are just other possibilities that our data could show, and you're going to have multiple alternative or alternate hypotheses, and it depends on what you actually are testing in your experiment. So again, if we're doing these minions, right, we're going to have as many alternative hypotheses as how many different types of fruit we test. So again, if we're going to put all this together, the null, again, would be that type of fruit has no effect on minion heart rate. Our H1 would be, or hypothesis 1 would be the banana is going to cause the minion's heart rate to be the highest. Our H2 would be the apple will cause the minion's heart rate to be the highest. And H3 would be the orange will cause the minion's heart rate to be the highest. So again, if we were testing more types of fruit, we would have more alternative hypotheses. And again, this makes it so that you don't, when you get to the end of your experiment and you get your data, you're not actually, it's not your opinion or what you thought was going to happen. It makes it so that you're not wrong. It's just whichever your data supports. So a lot of times kids like to say, well, I think that the banana is going to cause it to be the highest. Well, it's not going to be a failure if you're wrong at the end of the experiment. So that's kind of why we write them like this. So for our Clover experiment, we've been talking about Clover for a week or so now and how we're going to do an experiment with Clover. I have looked at all of your different questions. So you guys submitted questions a week or so ago, and I talked about how, we have to have an independent variable and a dependent variable in our question. And after reading all of them and talking to some of the other 7th grade science teachers, we have come up with an actual question that we're going to investigate. So here is our question. Isn't that a funny little pug picture? Okay, here's our question. This is what we're going to investigate. Does the amount of water that we give the clover affect the germination time? You might be thinking, well, what the heck is germination time? Well, let's look at this. So we've got our question, does the amount of water affect the germination time of clover? So our independent variable, what we're going to change, what we're testing, is different amounts of water. What we're going to measure, like I said, is germination time. What germination time really is the number of days that it takes to germinate or sprout or pop through that soil layer. So those are our two independent and dependent variables. We also have to start thinking about controls. So again, controls are things that you want to keep the same in the experiment, meaning you don't want these things to affect the result of what you get. So again, the only thing that we want to affect the germination time is the amount of water. So when we actually set this up, things that we're going to want to keep the same from plant to plant is amount of light, type of water, amount of soil, type of soil, method that we plant them, temperature of the room, size of the pot. There's so many other things that we have to consider. Because again, for example, method of planting, if I've got a pot and I plant some seeds like way down deep in the soil and other ones just kind of right at the top of the soil, that's going to affect germination time, because again, the ones that were planted super deep have to grow way more to reach the top of the soil than the ones that were just planted right on top. we don't want that to affect our results, because the only thing we want to be changing from plant to plant is the amount of water. So how we plant, the temperature of the room, all of these things we want to keep the same. The only thing that we want different is the amount of water. So those are some variables. One thing we have to kind of think about too is how much water we're going to use from plant to plant. So we've kind of talked as 7th grade science teachers just about what possible amounts we could choose. We haven't 100% decided this, but again, we know from doing our research that clover grows the best in like wet or more moist type of soil. We're not 100% sure if these numbers are going to be good, but it's kind of just a starting point where we can kind of just guess. So that's our independent variable. We're going to start out thinking that we're going to do some plants with 5 milliliters of water every day, some with 10, and then some with 20 milliliters. Again, our dependent variable is germination, which is the process of a plant developing from a seed to breaking through the surface. So again, in this picture, it kind of shows, I mean, this is like clearly past germination, but it shows kind of day one when they're planted and when they actually kind of sprout through the ground. So this is, at this point, we would say that the plant has germinated. Again, we have to have some sort of measurable data to collect, and we do in this case. We're going to count the number of days it takes from planting to sprouting, and that's going to be the number that we're going to write in our data table. So let's move on to hypotheses. So again, we've got our independent variable, amount of water. We're going to vary, 5, 10, 20, I think it was. And we've got what we're going to measure, which is the number of days it takes to sprout through the surface of the soil. And then again, we've got to be thinking, once we start setting up our experiment, we got to be thinking about those controls. So things we want to keep the same. So for hypotheses, again, our null means that whatever I'm changing has no effect on whatever I'm measuring. So again, for this experiment, what we're testing is amount of water. Our null hypothesis would be that no matter how much water I put on each plant, that does not affect the germination time of the clover. So what that would look like is the 5 milliliter, the 10, and the 20 milliliter water. All of those plants would be sprouting at the exact same time, meaning there would not be a difference at all between any of those plants and how long it takes to sprout. So that's the null. Again, that's not our only hypothesis. We've got these alternative hypotheses. And again, if we had more amounts or different amounts of water, more than just 3, we would have an H4, an H5, an H6. But we're going to kind of keep it simple, and we're just going to do 3 different amounts of water. So again, alternative is just the other possibilities of the data that we could get. So for our H1, we've got the clover watered with 5 milliliters of water a day will germinate in the fewest number of days, meaning it's going to be the fastest to sprout. H2 would be the clover watered with 10 milliliters of water will germinate in the fewest number of days, meaning the 10 milliliter one is the one that's going to make the quickest sprouting. Or H3, the clover watered with 20 milliliters of water a day will germinate in the fewest number of days. So again, we might find that the more water that the plant has, the quicker it's going to pop up through that soil. So those are our different hypotheses for this experiment. So tomorrow we're going to start talking about what it means to actually plan and test in an experiment. So we're going to talk about what makes a good procedure, what makes a good plan or a good set of directions, and kind of move on from there.
Mom, I'm really bored. Please, is Timmy around? Can I go play with Timmy? Timmy? Hello? Yes, hello, it's me, your best friend Rory. Wondering if you wanted to play.
Why, hello, Rory. How are you doing? What in the world are you wearing? Oh my gosh.
What? I am sorry. You know what? It is my time of the month. Dogs have issues too, so yes, I have to wear this lovely contraption to make sure that things don't, you know.
Well, that's really gross. What's wrong with you? What are you doing?
Well, you see, it kind of itches a little bit. All these straps and all these harnesses. And my parents make me wear these embarrassing suspenders, and just to keep the diaper on, and oh gosh, okay. Alright, one more spin. Okay, now I feel better. Alright, you want to go on a walk or something?